Welcome to Video 3, Perceptual and Conceptual Subitizing. In this video, we're going to focus on the distinction between perceptual subitizing, which we've been doing thus far, and conceptual subitizing. To begin, let's do some more subitizing ourselves. Watch the screen closely. How many did you see? If you saw 5, you're correct. The more interesting question is, how did you see it? During that quick flash, some people see 4 and 1, while others see 3 and 2. Let's try it again. How many? This one was probably more difficult. It's 7. Most people can only learn to effortlessly recognize up to about 5 haphazardly arranged items. But let's try another. How many do you see now? It's 9, a lot more than 7. Why was 9 so much easier than 7? The answer is visual structure. A set of dots can be impossible to subitize when there's no organization. But if there's a bit of structure that gives us some clues, suddenly we can subitize 9, 12, or even 22. In the previous videos, the kind of subitizing we were doing with very small sets is called perceptual subitizing because of the way the quantity knowledge feels instant. There's no other thinking involved. You just perceive 3. But that kind of subitizing has its limits. Without some additional visual organization, most people cannot subitize a set of more than 5. Here, however, we've entered the realm of conceptual subitizing. We call it conceptual because while there's still a subitizing element to it, there is also something else. You see suddenly and don't count, but you're also relying on other concepts or information you already have. Conceptual subitizing involves identifying the whole by seeing and combining the parts. In this figure, you might recognize the way the 5s are laid out as on the face of a die. So you subitize that there are 3 5s and recognize that this is 15. Perceptually subitizing 13 is not possible with random organization, but in this example, the use of a 10 frame makes 13 a lot easier to see. You can see the frame is full, and so subitize 3 on the outside, and see that the total is 13. We call quantities that are organized in frames or other familiar structures structured sets. And it's definitely the case that in math learning, teachers need to provide those experiences that help children progress. So knowing that maybe a child who is just subitizing 3 is not ready for 5 can help you calibrate the difficulty level for your teaching. It's also true that when a child's knowledge is not solid, it will be helpful to use the progression to go back to earlier learning to make sure that knowledge is firmly in place. In other words, the child who struggles with 5 might need to go back to 4 or even 3 just for a while. Note that the subitizing developmental progression clearly distinguishes between perceptual and conceptual subitizing. Perceptual subitizing develops well before and is foundational to conceptual subitizing. It's also true, however, that conceptual subitizing can occur with very small sets. You could see 3 as 2 and 1. And with a set size of 5, it's sometimes hard to know. Did we really see it as just 5? Or are we noticing a group of 2 and a group of 3? Regardless, when you are sharing set sizes of 5 or more, expect that some added visual structure will be needed to allow conceptual subitizing to take place. Because the range of normal development between the ages 2 and 6 is so broad, you could easily have children in your classroom who are subitizing across the entire developmental progression. For that reason, it's important to understand the differences between perceptual and conceptual subitizing. Conceptual subitizing introduces a completely different level of complexity. In the case of seeing this figure as 3 and 4 or 7, children must perceptually subitize 3, perceptually subitize 4, and then see the whole as 7, conceptually subitize, to ascribe the total 7. While this kind of complicated math thinking is both useful and exciting to see, there may be children in your class who can usefully spend a lot of time working with much smaller amounts. A focus on 3, 4, and 5 helps build the kind of automaticity and solid number sense that will allow children to eventually think in more complex ways. Automaticity is when a child knows how many quickly, as in 3 seconds or less, and a solid number sense helps children think flexibly about quantities. Together, automaticity and flexibility will help children learn and understand as the math thinking gets more complex. It's important that children are given adequate time to develop these qualities in their thinking about small quantities first.